Hello and welcome to Repair Solutions Pro how-to video series. I'm Eli Saldana and
I'm Steve Caruso.
Master Technician, Technical Instructor, and Automotive Diagnostic Specialist. In this video, we're going to walk you through the complete diagnostic and repair process for DTC P0599 Thermostat Heater Control Circuit High on a 2014 Chevy Cruze equipped with a 1.8 liter engine. Now, just keep in mind that the procedures covered in this also apply to the 2011 through 2015 Chevy Cruze models.
With the same engine, of course.
Of course. Unlike many vehicles that use a coolant temperature alone to control the thermostat, the Chevy Cruze uses a thermostat with a built-in heater. When the engine is under heavier load, the PCM can turn on the thermostat heater to help the thermostat open up sooner. This helps keep the engine temperature under control. Before starting any testing, perform a quick visual inspection of the cooling system, such as look for damaged, corroded, or loose wiring at the connector and connectors at the thermostat heater. Check the wiring harness for signs of rubbing, chafing, or heat damage, that sort of thing. Next, verify that the coolant level is correct and inspect the cooling system for any leaks. Also make sure that the thermostat heater connector is fully seated, secure, and free of corrosion or contamination. Check the service manual and any applicable technical service bulletins or TSBs before continuing to diagnose this code. Once the inspection is complete, we're ready to move on with the next step.
Once the visual inspection is complete, turn the ignition on with the engine off and use the scan tool to check for stored DTCs. In this case, DTC P0599 Thermostat Heater Control Circuit High is present. This code indicates a high voltage condition in the thermostat heater control circuit. Common causes include a faulty thermostat, damaged wiring, or a poor electrical connection. Next, review the freeze frame data, service history, and any applicable TSBs for clues about when the code was set. Now let's look at the possible causes of this DTC.
Some of the most common causes of DTC P0599 are low coolant level, faulty engine coolant thermostat heater.
All right, first we need to run a few tests to figure out what's causing this code. We'll go step by step. Step 1, inspect the coolant system. Start by checking the coolant level in the surge tank and inspecting the system for any signs of leaks. In this case, no leaks are found and the coolant level is correct, so we'll move on to the next step. If a leak is found, repair the cooling system first, refill the coolant to the correct level, and then continue with the next step. Inspecting the engine coolant heater circuit. First, we're going to check for ignition voltage and ground. The purpose of this is to verify the thermostat heater is receiving proper battery voltage from the ignition feed circuit. To perform this test, we're going to turn the ignition on, engine off. We're going to access the thermostat heater connector. We're going to probe the connectors. We're going to be looking for battery voltage during this test. We're going to use a voltmeter and we're going to measure between both pins. We're looking for a good battery voltage. Expected range would be about battery voltage, whether it's 12.6 key on engine off, 14.1 with the ignition running. If the voltage is out of range, then we will need to check to see whether or not we have a power source problem or a ground problem. Checking the thermostat heater control circuit. Next, we'll verify the PCM is in control of thermostat heater circuit. With the ignition on, engine off, connect the scan tool and command the thermostat heater to 100% duty cycle. Access the coolant thermostat heater connector, the blue wire, which is the control circuit, and leave the connector plugged in during this test. Using a multimeter, measure the voltage between pin 1 and a good ground while the heater circuit is being commanded on. The expected voltage drop should be less than 1 volt. If the voltage is within specification, the PCM is controlling the circuit correctly and the thermostat assembly should be replaced. If the voltage is out of spec, the control circuit wiring or connectors should be checked for an open or high resistance. Then continue the diagnosis. The defective heater is 7 ohms, which is about 2 amps. The new heater is 15.5 ohms, which is less than 1 amp. The old heater unit is defective.
The engine coolant thermostat heater is located in the engine compartment at the front upper left side of the engine, built into the thermostat housing. Before starting any removal procedures, make sure that the engine is completely cool. Never open up the cooling system when it's hot, as this could cause some pretty severe injuries.
1. Locate the drain valve under the vehicle. Remove the panel if needed. Place a drain pan under the valve on a flat surface. Then open the valve and drain the coolant. 2. Remove the upper hose clamp and slide the hose off the housing. 3. Use an E8 torque socket to remove the 4 bolts securing the thermostat housing. Wiggle the housing to release it from the engine. Then disconnect the heater inlet and heater outlet hoses. Before installation, ensure the mounting surface is clean, dry, and free of oil, coolant, and debris. One, position the new engine coolant thermostat housing against the engine. 1. Use an E8 torque socket to tighten the 4 bolts securing the thermostat housing to 71 inch-pounds or 8 Newton meters. 2. Reconnect the heater inlet hose and heater outlet hose. 3. Secure the clamps in their original positions. Then reconnect the thermostat heater electrical connector until it clicks into place. Then reconnect the upper hose and secure the clamp. Three, use a vacuum coolant refill tool to remove trapped air from the cooling system. Then slowly fill the coolant reservoir with the correct 50-50 DexCool coolant mixture until it reaches the full cold mark. 4. Start the engine. Set the heater to maximum heat with the blower on low and allow the engine to idle for about 10 minutes. Check the thermostat housing, coolant hoses, and surrounding areas for leaks, and add coolant as needed to maintain the proper level.
After replacing the faulty component, we're going to go ahead and perform a repair validation to confirm that, well, the repair was successful. Use your scan tool to clear the diagnostic trouble codes, freeze frame data, IM readiness data stored in the vehicle's computer. Next, you're going to want to review the trip cycle for the Comprehensive Component Monitor, or CCM. With the vehicle in the key-on engine running position, make sure that the monitor icon is green-gray, which means that everything is enabled.
Next, you follow the trip cycle shown in the scan tool or use the procedures listed in the service manual or emissions guide. This ensures that the OBD system rechecks the thermostat heater is operating correctly. After completing the trip or the drive cycle, use the scan tool to recheck the I&M readiness status along with any pending or confirmed DTCs. If no codes are present and the I&M readiness status is green, which means it passed, the system has been completed.
This concludes the diagnostic and repair process for DTC P0599 thermostat heater control circuit high on a 2014 Chevy Cruze equipped with the 1.8-liter engine. Now, the procedures demonstrated in this vehicle also apply to the 2011 to the 2015 Chevy Cruze models equipped with the same engine platform.
Thanks for watching, and for additional diagnostic information, repair procedures, and technical resources, Visit pro.repairsolutions.com. Thanks for watching.
Thank you for watching.